Okay, we're going to go over just everything that is on this review and what you need to focus on for your test. On this first section right here, there will be nothing on your test that actually makes you name these different items. However, within the test, it will refer to different types of angles and arcs and chords and segments and all of this stuff. So make sure that you know what it's talking about when it's used within the test. On this next section, you're finding your radius, circumference, area, or diameter, given one of those four things. So you're going to need to make sure that you know your different formulas. So for example, I know that my diameter is twice as long as my radius, which means my radius is 9. My circumference then is pi times diameter, which will be on your equation quiz to make sure you know that, but then it will be given to you on the top of the test. My area formula is pi r squared. And so you would use whichever appropriate formula to find your radius, circumference, diameter, whatever it may be. On ones like 3 and 4, where I give you either the area or the circumference, you will start with that formula. So for example, here on area, my area formula is pi r squared. And so I would set 49 pi equal to pi r squared and solve for that r. On number 4, same thing, but you would just have your circumference first. On 6 through 9, we are using our standard form equation for our circles. So x minus h squared plus y minus k squared equals r squared. And you're writing your equation. Remember that your h and your k are the center, and then you'd find the center here or here, and then the r is your radius. So you will square root it if I give it to you, or you'll square it when you plug it in. So you need to find your radius. On number 6, for example, you would use your distance formula to find that radius. On number 7, you're going to solve that equation very similarly to how we did on the ones before. And then on 8 and 9, you're just going to count it. On number 9 on here on the key, there is a typo. We accidentally just miscounted here. So make sure your center on number 9 is at -2, 3, and your radius is 2. So just double check that with the key. On the next page, you're starting to talk about your angles. First thing you want to do is figure out what kind of angle it is. So on 10, 11, and 12, these are central angles, which means on all 3, your angle is equal to your arc. Okay, and so in each of these, you'll set it up. So for example, since this BC arc is 53, so is the angle inside there, BZC. Okay, with these ones, the first thing we talked about last time was starting to find every angle and arc that you can, regardless of what I asked for. So for example, here, because this EC is the diameter, I know these 3 have to add to 180. So to get arc AB, I would do 180 minus 79 minus 53 is 48. To get CD, since this is marked as a right angle right here, I know that 53 and this arc CD have to be 90 in total, so 90 minus 53 gives me 37. And then I can go ahead and find ED using the diameter again, because ED and CD have to equal 180, so 180 minus 37 gives me 143. Again, find everything before you find any of it. So that's the same thing I would do first on number 11. On number 12, the hint I will give you is that these angles here are vertical angles, which means they're congruent. So think about how that affects your arcs then, if your angles are congruent. On these next ones, 13 is an inscribed angle. These are on the circle, so remember that your angle is half of your arc. Or what we said also is you can do 2 times your angle equals your arc. Either is fine. But what that means here, since this angle at J is 59, the arc M to L would be 59 times 2, or 118. So again, I would go through and find every angle and every arc, just like we did on the last ones. Use this diameter at JL, and then you can find everything you need. On 14 through 16, what you should notice is that all of those angles are outside of your circle. And so that means your formula is your angle is half of your far arc minus your close arc. So you make sure when you set this up, you put the angle in each arc in the correct spot. So make sure that if I'm solving for the angle, that's where your X is on this angle side. But if I'm solving for an arc on number 16, you're going to plug an angle measure in for this angle, so it should be equal to a number when you set it up. On 15, you're going to be able to find arc WZ first, so make sure you start with that. When you keep going, 17 and 19 right here are both inside your circle. So make sure that that is your angle equals half of arc plus arc. So you will add them together. Again, make sure you put your arcs in the correct spots and your angles in the correct spots, but then you solve it very similarly. Number 18 is inscribed, so number 18 goes back to day 6.2. On these next ones, again, they're the same way, so identify if they're in, out, on, or central, and then start to figure out your relationship. So for example, number 20, these angles are on the circle PQS and PRS. We had a very similar one like this on your homework, so think about how they're both related to this arc, PS right here, and how you'll find that then. 21, there was also one similar on your homework. Think about how M is related to the arc from K, or from L through K and to N. Since it is on the circle, the angle is half your arc, so you can find this arc. You can also do the same thing with angle K and how it's related to NL. And then 22 is in your circle, 23 is on your circle. So use those different relationships, refer back to your old homeworks as you need. 24 is outside of your circle. Please make sure when you subtract your close angle that you distribute it through on that one. That's going to be your tricky part. Okay, 25 through 32 are 6.4. When you start this, you want to figure out what it is. So for example, 25 here is your tangent-tangent theorem, which means they are equal. So you're going to set your two tangents equal to each other. On 26 and 27, these are your chord-chord theorems, since it's all inside your circle, which means you do part times part equals, see, part times part. Okay, and again, make sure you're staying along one segment at a time. So 27 times x equals 30 times 18. Don't jump segments on. On number 28 and 30, these are your secant ones. So this is your whole times your outside equals your whole times your outside. Make sure when you find the wholes that you add. So here it's x plus 7. Okay, that's going to be the trickiest part there. On 29, this is your secant tangent, so it is whole times outside equals outside squared, since that tangent does not have a whole or an inside in particular. 31 and 32 are going to be very similar to 25, where you just set them equal. So set your tangents equal to each other. So for example, if this 3y plus 1 is equal to y plus 7, and then you're going to be able to find every piece of this all the way around. On the next page, this goes back to day 2, where you are setting up to find your arc length. So when we are doing that, we had our 3 ratios that were always set up as part over total. And when you do that, our 3 fractions were either the angle over 360 equals arc over pi times diameter, or 2 pi r, either one is fine, equals area over pi r squared. You always pick 2 of these based on what they give you. So on 33 and 34, for example, both of them give you the central angle and want to know the length of the arc. So you'll set up these first 2 fractions and cross multiply. On 35 and 36, you want the area and you're given the central angle. So you're going to set up angle over 360 equals area over pi r squared. 37 through 39, you will be given the picture on the test, but these are the ones we are still doing arc length, so it's these first two fractions, but you have to find the central angle by doing 360 divided by however many sides your shape has. So go ahead and draw yourself a picture of that to see that. Number 4 is more of a 40 is no more of a challenge problem, but think about, since you are given the arc length and the area, you're actually going to use these two fractions. So think about what that would look like, and the answer is written there on the back for you. 41 and 42 through the end are our last day, so day 6.6. You're writing your equation, so that goes back to your generic form on the front page. So when you're writing the equation, you're using that x minus h squared plus y minus k squared equals r squared. And then on B, you're going to use the distance formula to figure out if you're eligible. On 43, you are going to find the area of the first circle and then multiply it by 3 and solve for that radius. So you're going to figure out that the first circle has an area of approximately 50.3, and you're going to triple that to get 150.8, and then you will be able to solve for your original area, or for your original, your new radius by dividing by pi and square rooting, and you will get 6.9 for your new radius. When you moved your circle, make sure to find your original center. So my original center, looking at that equation, is at 2, -1. And then think about how you moved it. We moved it up 7, so that's plus 7 on the 1. We moved it left 3, so that's -3 on that, which means my new center is at -1, 6. And then you'll write an equation with that as your center. You'll then be able to also find C and D using the area you found in part A.